Hey, what's going on YouTube? What's up? So let me make sure that we're actually live. Yes, I think we are. How's it going? What's going on? So if I remember correctly, today is number 17 or 16, relearning linear algebra. Today's going to be a really fun stream. The title says ChatGPT enters the stream, or enters the chat, or something like that. So this is going to be really fun, I think. I hope you stick around for it. If I check out my retention graphs, everybody drops off after like 5 seconds. But I implore you, this is going to be a fun one. If you enjoy it, leave a comment and subscribe. Let me know what you enjoyed about it at the end of the video. That would help me a lot. And so if it's not clear yet, this is a live stream. I am streaming every morning, roughly at about 10 a.m. Eastern. So this is a brand new channel. The point is I'm trying to document and share my journey relearning mathematics after a long time away from it. I got a bachelor's degree a long time ago, and now I'm relearning it for fun instead of having aspirations to become a mathematician and do research and all that, sort of stuff. All right, so let's get into it. Why are we adding ChatGPT to the stream, and what does that mean? Okay, so a lot of ways in which that's true, I feel, but yeah, so one thing that is unique, one thing that I'm shooting for that's unique about this channel, and let me know if this sounds interesting or not, is, especially as somebody coming back to math, I'm not learning linear algebra for the first time, but I genuinely am very rusty on all of math. I'm finding it incredibly useful and also educational to use multiple books at the same time. So right now on this stream, we've primarily used Introduction to Linear Algebra by Gilbert Strang, one of the most beloved textbooks ever. Really great for an intro book. And then I'm also primarily contrasting that with Linear Algebra by Shilov. I love that book because it's very cheap. If I stop being lazy, I'll set up like an affiliate link and you can buy it from my storefront and I'll make half a penny or whatever. It costs like $15 on Amazon. It's so worth it. It's incredible. It's small. It's easy to carry around. Downside, really hard. Not the book I wanted to get. The book I wanted to get is closer to Strang, but the ideal book is neither of them. Like, the ideal book for me is somewhere in between. I want something that's somewhat rigorous, but not too rigorous. I don't want a theoretical proof-based linear algebra book, because that's the way that I was taught linear ages ago. Even my intro class, we did computations, and we learned how to do matrix calculations, and it was taught the right way, which was starting by solving systems of polynomial equations, systems of linear equations in particular. It was taught the right way, I think, because of that. But it lacked, in my opinion, the actual real-world examples and real-world applications of linear algebra. And for good reason. Like, you can only fit so much material in one course. And so we decided to do a little bit more theory, and I'm truly grateful for that because I fell in love with the theory and I changed majors from chemical engineering to mathematics. Yeah, and I love theory. I love proof-based, rigorous, axiomatic mathematics, pure mathematics. And so I focused on that, and my second course was more of an upper division undergrad split with some graduate students. Second course in theoretical proof-based linear. Shilov's book is a lot more like that. And Axler's book is, I don't know, it's very much intro to linear algebra, but to its credit, it has great examples. So, how did I get on this topic? My point was, a unique aspect of this channel is I'm trying to compare and contrast multiple books at the same time. Like, what does this author define? How does this author define a vector space? Like, what order of material does Shilov present linear algebra as opposed to Axler, as opposed to et cetera, et cetera? This week we were motivated a little bit by Markov matrices. And that's because when I was a TA and I graded linear algebra homework sets ages ago, that professor used Markov matrices to motivate matrix multiplication, like the first sort of module. And I thought that that was the coolest thing. Like, even before eigenvalues and eigenvectors, he just showed how you can think of these, like, they can represent probabilities of flipping a weighted coin or other things, or like probabilities that people move from Denver to Los Angeles or whatever. And over time, how does that probability approach a limit? I thought that that was so dang cool, because I hadn't seen that in my course. So I only saw a tiny bit just by grading the homework of other people learning that. And I just remember that ever to this day. I just was like, dang, that looked really cool. I want to learn that someday. So this week, our goal was to see a little bit about Markov matrices. And over the last couple streams, we tried doing that. And I briefly got to this topic yesterday. I think it's really cool to try using ChatGPT as another resource. I have several now. I have too many, perhaps, but ChatGPT has been pretty cool as another one. I highly would not recommend using ChatGPT as your only textbook. That would be a bad idea. Do not do that. But use it as a secondary resource. It's like pretty freaking cool, I think. So I want to get your reactions. What do you think? How is ChatGPT doing? We're going to showcase, we're going to ask it some questions today. If anybody tunes into the stream, I don't have view counts up, so I don't even know if people have shown up yet. But let me know in the comments if you watch this video after the fact. How do you think ChatGPT did in these questions? And as an exercise to the reader, anytime that we get an exercise broadly defined, feel free to pause the video, think for yourself, what is the answer going to be? Like, pause, write it down quickly, or just say it out loud somewhere. I don't know, just pause and reflect before you see the answers. Like, what will the answers be before you look at the answers? That's a big life pro tip for you. Like, that's a way more active way to learn mathematics or any subject that you're learning. And it took me too long to realize that. All right, let's get going. So, I need a breather for 1 second, and I'm going to pet my... Oh, no, she's sleeping now. My beautiful cat, Kaya, is in the background. She photobombed this photo yesterday when I was trying to create a thumbnail, so I was like, whatever. Let's lean into it. Let's just highlight my cat for some reason in the thumbnail. So let me know what you think of that. Coffee. Okay, let's do this thing. iPad should be connected correctly. Math, iPad, horizontal plus Sony. Yeah, I want this look, I think. This one. And what else do I need to do? I need to double click this for some reason. Okay. And now that's working. And now this time, can I... Yesterday I couldn't hide that. Now I can. There we go. We're getting somewhere. Pardon me for 1 second. This won't take long. I just want to, I want to get this iPad full screen for this one because we've got text and whatnot. So my face is chopped off a little bit, but whatever. You'll deal with it. Okay, so here we go. Let's find out. Pro tip. Just found out yesterday that OpenAI added folders, like project folders, to the app at least, and also to the web page. It's super freaking useful. I'm so happy because I was like, I don't want to see all of my random chats on the side. So I created a new math hobbyist folder, and I briefly had like a little chat. So there's a teaser. The last thing I said was, I love it. Thank you. I might use a generated thumbnail for my next video. So I think that'd be fun. Maybe we'll try to use one of ChatGPT's generated thumbnails, and we'll see that in the future. There's a teaser for you. Okay, let's do this. All right, so this is motivated by two things. One, when I was on the airplane coming back from Cancun last week, I guess I asked it a few questions before we took off, like while I was in the seat and before we took off, or like maybe waiting to board. I forget when exactly, but I started asking it some questions, and I was like, I'd like to learn about Markov matrices. Can you help me out? Basically. So that's one experiment I want to run here. Second experiment is that just a couple days ago, one viewer on the stream said, I was like in the middle of calculating, by the way, this is a live problem solving stream, by the way. So if you're here for that, some of these videos are doing that, not this one, but other ones. So I was in the middle of calculating some problems from string, eigenvalues and eigenvectors. That's the part of the book where string introduces Markov matrices. And I was in the middle, I was deep in the thick of it, calculating. I had my A minus lambda I determinant going on. And somebody had this nice comment in the chat where he or she said something like, hi, new viewer or something. I really like math, but I don't know what's going on. Can you explain? Or something. And I don't always pause to interrupt the flow of things and answer every question like that, because then otherwise these videos after the fact become more boring. But that one I was like, yes, I do want to answer this question. And I tried to give my own rapid fire. I tried my practice attempt there was, can I catch this person up in 10 minutes? And I haven't even looked. I haven't even gone back and looked at how long it actually ended up taking. It might have been 20 minutes. I don't know. But my goal was, can I catch this person up from zero? I don't even know what they know and what they don't know. But can I catch them up from zero to eigenvalues and eigenvectors in 10 minutes? Because I don't want to... I think I had to go. I think I had a hard stop at the end of that stream. My other cat is meowing. So that was fun. I thought that was very, very fun for me, especially as a hobbyist. So I tried to do my own introduction to linear algebra. And I think that would be a cool second experiment to try to replicate with ChatGPT today with y'all. So this should be fun. I want to start non-chronologically with that experiment, which would probably be a little bit better for some of the audience who may not have seen, what the heck is going on? I'm interested. There's a lot going on here, but what is linear algebra? So I want to try to replicate that experiment as much as possible. And final thing before we get started, final thing is a huge part of why I want to do this video right now, and why I want to share, especially ChatGPT, with y'all. It's because literally ChatGPT is just gigantic matrices. Literally, ChatGPT is linear algebra, everybody, okay? It is linear algebra and probability together. It's Markov matrices. It's stuff like Markov matrices. Now, that's a lie. There's a lot more to it. There's a lot more to it, but it's step one. It's the very beginning, and at the end of the day, it is humongous special matrices that we found that are amazingly useful. So, to me, linear algebra is this incredible, it's the perfect math, if you ask me, because it is so unbelievably useful. Most real-world engineering problems you reduce down to linear algebra, not calculus. Linear algebra, I've never worked as a traditional engineer, but I think that most engineering problems are solved by linear algebra, not calculus. Am I wrong? Like, fact check me, please. Somebody leave a comment in the comment section if I'm wrong or if I'm right. Do you use linear algebra in your day-to-day, et cetera, et cetera? So it's the perfect math because it's very useful. A second course, you can take a second course in linear algebra that's just 100% applications. Or if you're a math major like me, you probably will take a second course that's purely theoretical. Let's get back to the full. I'm yapping again. All right, so we're back to the full camera for a second. So if you're like me and you're a math major, you'll probably take a theoretical second course in linear algebra, and it's gorgeous, okay? It will train you to think. It will train you to reason, just like any other pure math class will. If you just want to see pure math, I would recommend following my number theory series, or better yet, pick up your own number theory book. And like intro to proofs. Or if that doesn't interest you, pick up a book on abstract algebra. But like linear algebra is the first step to that stuff. And there is a full proof-based theoretical pure linear algebra. And really at the upper division level of undergrad, like the lines are just super blurry. Like all math is all math at some point. But yeah, so to me, it's a perfect math because it's very applied and useful and very theoretical and pure and beautiful. So let's find out. Nowadays, I'm just way more interested in applications. I want to refresh the theory again, but I'm not trying to become a research mathematician like I used to. Nowadays, I'm way more interested, like, also not because I want to calculate. I don't want to build ChatGPT, but I'm just curious. Like, I want to understand and learn because I haven't seen that before. Like, what does applied linear algebra look like? I vaguely remember a little bit about Markov matrices, and so we'll get there. And I want to showcase to you why ChatGPT, like one incredibly useful bleeding edge use of linear algebra. So I hope you're here for it. I hope I haven't lost you. Let me know if I've lost you. Leave a comment below if you clicked away. All right. Let's go. Let's do this. This one? All right, let's go. So, 2 questions. I'm going to do it as 2 separate chats, I think. Hi. I would like maybe we'll phrase it this way. I don't know if I want to mention that I was in a stream. I don't know. Like I could try to like relay that exact scenario, but I think I'd like to say I would like a brief explanation of linear algebra that I could explain to someone who may or may not. Let me say, to someone who probably hasn't seen it before. I would like a brief explanation of linear algebra that I could explain to someone who probably hasn't seen it before. More than an elevator pitch. But still less than 10 minutes. Maybe let's imagine I have a whiteboard. So maybe it's a co-worker. Maybe it's explaining, maybe I'm explaining it to a coworker before a meeting starts. To me, that, I don't know, I haven't thought of this before, but that kind of feels like a cool equivalent, like a little more than an elevator pitch. More than an elevator pitch, but less than like a full presentation. It's like other people are running late for this meeting again. So we've got about 5 minutes. You want to see something interesting on the whiteboard? I don't know. I've never thought of that before. Like a, pre-meeting pitch. Okay. I'm going to go ahead and say thank you because I like to say thank you to the robot. Thank you. Let's see, how does it do? Oh my gosh, this is so cool to me. Like, I just geek out about this. All right, so what can we do? There's a lot of margin on the side, so what we can do is make this look nicer by moving that to the side. I can shrink this. I can move my camera over. All right, that's a little bit better. I moved the wrong thing. Okay, here we go. Let's do this. I think that's good enough. Good enough. All right, let's do this. And maybe the cat will show up in the... No. All right. Okay, so let's do this. I hope you can read that. I could also try to zoom the window a little bit more. At least get rid of that bottom part where you can't. It doesn't matter if you see the keyboard thing or not. Okay. All right, let's do this. All right. Hi, I would like a brief explanation of linear algebra that I could explain to someone who probably hasn't seen it before. More than an elevator pitch, but still less than 10 minutes. Let's imagine I have a whiteboard, so maybe I'm explaining it to a coworker before a meeting starts. Thank you. Sure, here's a concise, structured way. Oh, and I don't know if I said this explicitly, but part of the goal here is I want to compare my own presentation to this person. I'll go back to the other video and rewatch it. I want to compare my own explanation to maybe a better one. I'm going to assume it's better. Spoilers. So this is a practice stream. I'm trying to practice. and practice, deliberate practice. All right, here's a concise, structured way to explain linear algebra in less than 10 minutes using a whiteboard. The key is to keep it intuitive and relatable, building up from familiar concepts. 1. Start with scalars, vectors, and matrices. 2 minutes. Scalars. Start simple. A scalar is just a single number, like -3 or -5. Okay. ChatGPT, you're embarrassing me. I was hyping you up. Come on, bro. I thought you were going. I believed in you. Come on. What's going on? All right, let's do this. Let me just zoom a little bit better. Here we go. Now that looks nicer. Start with scalars, vectors, and matrices. 2 minutes. Scalars. Start simple. A scalar is just a single number, like 3 or -5. Vectors. Then introduce vectors as collections of numbers, usually written as a column or a row. They represent things like direction and magnitude in space. Example. V equals 2, 3 represents a point in 2D space. Matrices. Finally, explain that a matrix is like a grid of numbers. Example, A equals 1, 2, 3, 4. Unfortunately, I can't zoom in and out on this. Well, maybe I could, but I'm not going to. They're used to transform vectors or describe systems of equations. Okay. Point 2. Show linear transformations. 3 minutes. Draw a coordinate system and a vector v. Example, v equals 1, 2. Or a column vector 1, 2 with brackets. Explain that multiplying a vector by a matrix transforms it. A times v equals this matrix times this vector equals 2, 6. This scales the vector differently in the x and y directions. Relate this to real-world examples, like rotating a camera view or resizing an image. I like that. So there are parts of this that I've done in the stream, and then parts of this that I haven't done. I have absolutely mentioned rotating a camera view to my credit. So I didn't do it in that brief 10-minute run, but I know I've done it in the past on this stream. Okay. 3. Connect to systems of equations. 2 minutes. Write a system of equations. X plus 2y equals 5. 3x plus 4y equals 6. Show how this can be rewritten in matrix form. A times x equals b, where A is this matrix, x is xy, b is 5, 6. Linear algebra provides systematic ways to solve these systems, even for very large numbers of equations. Cool. 4. Eigenvalues and eigenvectors. 3 minutes. Explain with intuition. Sometimes a matrix transformation stretches or compresses a vector without changing its direction. Yes. So we've been doing this over the last week. So I'm proud of myself that I have been focusing on eigenvalues and eigenvectors. Cool. Write the equation AV equals lambda v. Here, v is the eigenvector, unchanged direction, and lambda, the eigenvalue, is how much it gets stretched. Okay, application examples. Google's PageRank. I got that one. Uses eigenvectors to rank websites. Physics. Eigenvalues describe natural frequencies of vibration. Boring. I would never use that example. Why it's powerful. Wrap up. Why it's powerful. Wrap up. Okay. Yeah, here we go. You can see this. Linear algebra is a universal language for anything involving data and space. 3D graphics in a video game. Machine learning and data analysis. Yes. Engineering simulations and physical systems. Summarize. It's about understanding systems of equations, transformations, and how to represent and manipulate data mathematically. This should give them an intuitive understanding and spark curiosity. If they ask questions, you can dive deeper into one of the examples or concepts. Yeah. Okay, I have so many reactions. I have so many thoughts, but please leave a comment below. Pause the video right now. Exercise for the reader. What are your reactions to this? Like, literally, what are your thoughts? How did it do? If you know linear algebra, how did it do? If you don't know linear algebra, maybe even better, if you don't know linear algebra, do you feel like you know what linear algebra is now? Do you feel like you have a decent sense? Thirdly, if you've seen my streams, how am I doing? Because I'm a weird hobbyist trying to explain all this stuff as I go in a weird blend of me learning math for fun for myself as well as trying to teach an audience at the same time. How am I doing? Maybe you could just skim my titles of my videos. Yeah, there are some clear differences. Cool. Well, before I get detailed on my reaction, and this is an honest, authentic reaction. I haven't asked it this question. I asked it the other questions about Markov matrices, which we'll get to. How long has this been? How long have we been live? Is anybody watching this? What's going on? How's it going, everybody? All right, I have no idea. How long have we been live? I want to, for once in my life, make a video that's not like 3 hours long. We're already 30 minutes into this video. We may not get to Markov matrices, or I'll just like rapidly show it and not talk through it. Dang it! I keep yapping, y'all. I hope you enjoy it. Let me know if you enjoy it. Let me know if you wish I would just shut up. Cool. So, reactions. Number one, this is incredible. This is so goddamn cool. Like, the day ChatGPT came out, I was like, whoa. Like, I told my coworkers, I was like, whoa, this is the... So I worked in software. Right now I'm trying to do my own thing. But at the time, yeah, I worked at one of the big companies. And the day it came out, I told my teammates, I was like, whoa, there's this brand new AI thing, like this new AI development. This is the first one that I'm super impressed by. This is the first one that I think could take jobs someday. And they're just like, yeah, whatever. But like, I really meant it, and I still mean it. I've been paying attention to machine learning and artificial intelligence broadly since I was pretty young, since the early 2000s. Like, my dad is an electrical engineer, and he has some patents around applying like before deep learning, but just like the simpler neural network models. I remember him showing me like a demo of like some sort of stick trying to balance on a skateboard or something. Like, you apply random forces and it falls over like 400,000 times really quickly, but then it eventually learns how to balance and it learns how to skate. And I skateboarded. I don't know if that's why he showed me that example, but I love skateboarding, and I was just like, whoa, that is freaking cool. Like, that's neat. But then at the same time, I was also like, yeah, whatever. Who cares? I don't want to learn to code. But yeah, so like ever since, I have been passively watching and following the AI development news. Like, when like I considered doing a senior thesis, trying to learn a little bit about computer Go and some other things. And yeah, and I don't know all the words, I've forgotten the details, but like every step along the way over the last 10 years has just been unbelievable. And I'm just like, this stuff is moving pretty fast. But ChatGPT, the day that came out, I was like, this is the first one that I'm actually impressed by. This is the first one where I'm like actually blown away by. This is incredible to me. This isn't bad. So please let me know in the comments. Do you feel like this was a decent 5-minute intro to linear algebra? And it's valid if the answer is no. I will critique it in a second here because I took a very different approach. Let me switch away to make sure I don't show anything I don't need to show. Oh, my cat is sleeping in the background. She's so cute. Her name is Luna. The other one's name is Kaya. They are both lovely. Okay. So I could show the one that I did again yesterday, or let me just quickly show the one that I actually showed in that moment to that user, to the viewer. They're not users, they're viewers. I'll try to use this one. Okay, so here we go. We're in my iPad. We're in my Notability scene. This is usually where we are on the stream. Okay, so I was doing a bunch of eigenvalue problems and stuff from Strang, and then we came, we came down here to this question. We got to this question. Somebody, shout out to Abhinav, asked, "What's going on? I'm in grade 10." And I started out saying, I have no idea what you know, what you don't know, but my guess is you've probably seen how to solve equations. I bet that you've learned how to graph a line. In America, we use the term y equals mx plus b, but no matter what, they are always equations that look like x plus y equals 1 or x plus 2y equals 2, for example. So if you have an equation like that, that's called a linear equation. You can rearrange it in a way so to this other form where m is the slope and y is the, or b is the y-intercept. You with me? And he was like, yeah, oh yeah, I've seen this before. I was like, okay, cool. Well, now that I'm already on this path, I'm going to continue this direction. Well, we can rearrange those equations. Y equals negative x plus 1, y equals negative 1/2 x plus 1. And we can find the point where these two intersect. So right here in this blue dot, these two intersect in this spot. That looks like 0, 1, right? But there's some cool theory around the fact that, that's more trouble than it's worth. But there's some cool theory that you can try to understand where sometimes you can have another equation and there are never any solutions. Because if you have two parallel lines, they'll never cross, right? There are times when there are 0 solutions. And then there are also times when there are infinitely many solutions. For example, if I overlay this with purple and I write two different equations, y equals negative x and 2y equals negative 2x, well, those are just two different equations that actually mean the same line, right? You've seen how to solve this equation for this value. And the standard way to do it, you can do substitution. And he mentioned that he or she mentioned that in the chat. They said, oh yeah, you do substitution right here. You do substitution, and then you plug in, you solve them both for y, and then you plug in one of the y's for the other y, whatever, you know what I mean. And I was like, yes, absolutely, and we solved 0, 1. And then I said, there's actually another way that they also teach in high school called elimination. with elimination, you can add and subtract rows. You can add and subtract those equations to each other. You may have seen this, you may not have, but it's really useful if you have more than two variables. So let's do it by elimination. I guess I didn't work it out by elimination, but I just said, well, it turns out that you can, where did my matrix go? It was down here. I said elimination. You can write down those exact same equations, but you can just omit the variables. This one still means, the first line still means x plus y equals 1, and then the second line means x plus 2y equals 2. And I can subtract the first row from the second row right here, and then I can subtract the second row from the first. This literally now is the exact same steps that you would have done, that you learned in high school, adding and subtracting equations. But what's nice is this notation actually makes it so much easier to solve this quickly, because you don't actually care what the variable names are. That doesn't matter. You can call it alpha or beta or x1, x2, y, z. You can call it whatever you want. Like what we care about is this pair of numbers, 0 and 1, right? But what's amazing to me is, like maybe solving it 2 by 2 is not that different, but like I said, if you solve for more than two variables, it's so much more efficient. Not just for humans, but also for computers. For example, it's not really true, but you can think of ChatGPT as a 5 billion by 5 billion sized matrix. And all we're doing is just adding and subtracting lines to this humongous, amazing matrix. There's also matrix multiplication and a lot of other cool stuff that you'll learn about linear algebra. But at the end of the day, linear algebra is unbelievably useful. It's so useful for artificial intelligence. It's useful for video games. Originally, we found that it was super useful for video games, like to rotate a camera or something. And NVIDIA built, and other companies built GPUs. These are computer chips that are super efficient at solving matrix problems, right? They're just built for these types of problems, of just working well with humongous grids of numbers. And then, many years later, now OpenAI and others have applied these GPUs, and they've applied linear algebra to build AI, and it's so incredibly cool, because it was my favorite class in college, and now it's just making a huge comeback in a sense. Or I never expected linear algebra to be this widely popularized right now. So there you go. There's like the very brief, short intro, little Jimmy or Abhinav, whatever your name was. I can briefly just say that I'll briefly say that the way to understand if two lines or 500 billion lines have one solution is there's something called the determinant, and if sorry, that was not actually part of it. I just showed it somewhere. I think I don't remember exactly what I did. I think I skimmed through some of the other exercises or the stuff that I had done earlier in the stream, and I said one detail is some of the beautiful theory that makes linear algebra beautiful, not just applied, is that we now understand a lot of theory about when there's exactly one solution for a humongous system of equations. It is exactly when this determinant equals 0. I'm running out of time, but it's not that different from something you may have seen solving the quadratic equation, the discriminant. You may remember the nursery rhyme song, whatever, b squared minus 4ac. If this thing, there are like 3 cases with a discriminant in the quadratic equation. If it equals 0, it can equal 0, it can be less than 0, or it can be bigger than 0. If it's less than 0, there's 0 solutions. If it equals 0, there's 1 solution. And if this thing that lives under the square root, if this thing, b squared minus 4ac, is greater than 0, then there's exactly 2 solutions. So the discriminant, so this one is for quadratic equations. Quadratic equations, which look like ax squared plus bx plus c equals 0. And the this thing is called the discriminant. It's a fancy name. This thing, which I don't have time for, is called the determinant. They kind of sound similar, right? So at least in my mind, maybe that's why they chose those names. And this thing equals 0 if and only if there is one solution. If it's... Oh, wait. Oops. The determinant is not 0 if and only if there's one solution. If it is 0, they might be the same line and there's infinitely many solutions. Or they might be parallel lines and there are 0 solutions. Even in 3-dimensional or 500 billion dimensional space or whatever. So that's all we have time for. That's also all we have time for on this YouTube video. Y'all, please let me know. I'm actually genuinely, I don't know. I'm not as impressed as I thought I would be on this particular answer. I am unbelievably impressed on the one hand. I'm unbelievably impressed by how good this is, because it's not wrong. And a lot of linear algebra classes, this might be the standard treatment of linear algebra. This might be the standard treatment of linear algebra to people who just finished a calculus class, and they're pretty sharp in their math. But it's not a very good explanation to somebody who's rusty at math or who has not, it's not a good explanation to a 10-year-old. And these days I'm much more interested in explaining math to 10-year-olds and to 60-year-old retirees. So hit me up, email me, themathhobbyist@gmail.com if you want a personal tutor for you or your kid. And here's my reactions to this ChatGPT answer. It is concise. It is very structured. I don't know if you could get this done in 10 minutes. I'd be so impressed by somebody. I have a habit of yapping. If you practice this in advance, maybe you could do it in 10 minutes. But no, yeah, right. I don't think so. I think it would take 10 minutes just to do the first part. But yeah, you can try to... refer to something called a scalar. That's a scary sounding word. A scary sounding word is vector too. Like, I want to go straight to, like, why is it called linear algebra? It's because we're solving systems of lines, like a more abstract idea of lines. We're solving systems of equations, which you've probably seen. You might remember how to do this. There's a more abstract idea of what a line is that works for three-dimensional space or even infinite dimensional space. That's how I would explain it to somebody. Matrices is like a grid of numbers. I use that. I always say it's a grid of numbers. I like that phrase. They're used to transform vectors or describe systems of equations. There, yes, that's where ChatGPT messed up this time. Unfortunately, I just realized I think I'm talking to 4.0 this time, so I just screwed up. I meant to use 03. My bad. That was not intentional. Yeah, so this, I think, is a relatively old model. Oh, yeah, and I saw this yesterday. The mobile app doesn't allow you to change the model, but the web app does. So, pro tip to anybody out there. There's project folders, and they're great. You can also change the model now, which is awesome. Or, no. Blah, scratch that. There are project folders, and if you use project folders, use the web app so that you can change the model. That's what I meant to say. So, as of today, whenever today is, start with scalars, vectors, and matrices. Show linear transformations. No, you were on the right path with the last sentence, describe systems of equations. Start with that. Describe systems of equations. Only do that. If that's the only thing you have time for, and it probably will take all 10 minutes, just talk about solving systems of equations, because that's what we use them for in the real world, if I understand correctly. Then show linear transformations. Nope. Big nope to that one. I would mention rotating a camera view. Resizing an image is a cool example. I haven't thought of that one, but I might mention that as a vague, this stuff is super useful in the real world to solve applications. Like, you can use this stuff to build video games, so that Mario can spin around in a circle or whatever. So linear transformations, Giant disagree on that one. On this channel, I've skipped linear transformations completely, and we'll probably talk about that in better detail next week that we resume this, in probably 2 weeks. Connect to systems of equations. That's where I'd start. I thought I would do that. I like a little meta note. I like that it uses my favorite numbers, 1, 2, 3, 4, 5. Oh, wait, no, it didn't. It was almost there. Well, no, it did. It did in the matrix. 1x plus 2y, and then 3x plus 4y, and then 5 and 6 on the right. I like to do 1, 2, 3, 4, 5, 6, but you do you. It doesn't matter. I just like using 1, 2, 3, 4, 5, 6 everywhere I can. Show how this can be rewritten in matrix form. Write the system of equations. Show how it can be written as a matrix. And then claim linear algebra provides systematic ways to solve these systems, even for very large numbers of equations. Yeah, I don't like it. I mean, I would just spend all 10 minutes actually doing that, and I would actually do it both ways. Clearly, like, that's what I actually did in stream. Eigenvalues and eigenvectors. I'm glad that it's mentioning this, because this is one of the very useful and beautiful parts of linear algebra, and that's why we've briefly touched on the idea this week in this channel. I did it. I've been talking a little bit about eigenvalues, eigenvectors to understand Markov matrices. And I guess ChatGPT is briefly mentioning that implicitly by referring to Google's PageRank. I like that ChatGPT referred to PageRank. I do like to tell people linear algebra, like literally Google was built on linear algebra. Like the algorithm to rank the list of websites when you search for something is linear algebra. It is the stuff we've been studying this week. And then the second example, physics, engineer, or eigenvalues describe natural frequencies of vibration. I hate that example, and I would never, in a million lifetimes, use that example. The reason I don't like ever using physics as an example is that most high schoolers, for example, who are not math people, have decided that they never want to do physics and they don't want to do engineering. They don't care about these things. Like, I mean, I don't know. In your day-to-day life, you're not talking about natural frequencies of vibration. Like, that's just not a very intuitive explanation. I don't know. I would avoid that like the plague, personally. Why it's powerful, wrap up. Linear algebra, universal language, anything involving data in space. I like that phrase, anything involving data in space. I'm gonna use that. Anything involving data is just so true. 3D graphics and video games, check, I did that. Machine learning and data analysis, check, I did that. Engineering simulations and physical systems, I would recommend against that one. I just keep it vague. So many things in the real world. I guess I have said it's super useful for engineering, but that's the level of detail I would go with. Nothing wrong with engineering. Engineering's obviously wonderful, but you have to meet your audience where they're at, I think. This should give them an intuitive understanding and spark curiosity. If they ask questions, you can dive deeper into one of the examples or concepts. Yeah. Okay. So, leave a comment below. I would love to hear your thoughts. How did ChatGPT do? How did I do? Are you as impressed as I am that we even got this answer? Because I think that this answer is unbelievably cool. And I think the newer models are going to do an even better job. So we'll try running this experiment again in another stream, unfortunately. But let's briefly tease this other one that I did actually do on the plane. I'm going to do this, and you let me know what you think. How did it do? And try to work the examples for yourself, etc. Hi, I'm relearning math as a hobby after 15 years away from it. BS, pure maths, small, focus on number theory. I loved linear algebra, and now I want to better understand some of its applications. In particular, I've heard about Markov chains. Can you give me a brief introduction to the theory in a step-by-step way? I'd like one exercise at a time to solve. Starting easy, starting, let's say, simple, then progressively introducing new concepts as we go. Thank you. All right, so how's it going to do on this? Here's a little teaser. Here's a starting point. If you're interested, I made a video a couple days ago trying to write down verbatim the definition of Markov matrix according to Strang, Shilov, Axler, and Norris. So those are 4 different books of different difficulty levels and different focuses. And let's compare. Let's compare against ChatGPT. Welcome back to math. That's a nice warm intro. Markov chains are a fantastic application of linear algebra, and I'd be happy to guide you step by step with explanations and exercises. Step 1, the basics of a Markov chain. A Markov chain models a system that transitions between states, where the probability of moving to a new state depends only on the current state, not the history. These probabilities are represented in a transition matrix P, where each entry, Pij, represents the probability of transitioning from state I to state J. Okay, that's a little bit more than I remember from the plane. I wonder if it's because I mentioned that I am coming back and I had some prior experience in math, like a bachelor's. So I think I think I worded it slightly different, but anyways, these things are not going to be very reproducible. It's going to give you a different answer most of the time. Step 1, the basics of a Markov chain. Oh, I already said that. Exercise 1, understanding transition matrices. You're managing a small shop with 3 customer moods. I like this. Ooh, it used like a population example the first time. A, happy. 50% chance they stay happy. 30% chance they become neutral. 20% chance they become unhappy. That is such a cool example. B, neutral. 40% chance they become happy. 40% chance. 40%, 20%. 3, C, if the customer is unhappy, there's a 20% chance they'll become happy. 10% chance they become neutral, and a 70% chance they stay unhappy. I love this example. Write the transition matrix P for the system. Each row should sum to 1 because probabilities are normalized. 2, verify that all rows add to 1. Let me know when you're ready to proceed. This, I'm just going to say it now. After reading Strang, after reading Shilov and Axler, spoilers, Markov doesn't appear in those books. And after reading the first page of Norris, ChatGPT just did a better job. All right. Here, let's... my name is John. I am the math hobbyist. I'm available for tutoring if anybody wants it. I am hanging out, streaming my practice sessions here almost every day, roughly at about 10 a.m. Eastern at the moment. You can join the Discord if you want to find out the latest schedule. Discord.themathhobbyist.com. If you want to buy me a coffee, I'd be forever grateful. Coffee.themathhobbyist. Really, all of these little short links, just use them before themathhobbyist.com. What else am I missing? Those are the most important ones. I feel like there was something else. Next week. Oh no, let's do this one. Goals of this stream. Understand the proof of Fermat's last theorem. 2. Master linear algebra. 3. I don't know, some other stuff. And then last goal, have fun. We're just here chilling and having fun. Like, literally, this is a hobby for me right now. Okay, the math hobbyist. Thanks for watching, everybody. This was really fun for me. I hope you enjoyed. Like and subscribe and share. And